Hello students, hope you all are enjoying and you have practiced enough. Okay, so we are doing motion in plane today in lecture 6. We are going to do resolution of vectors. Okay, we had done already vector addition. Now we are going to do resolution of vectors. See, this is very simple actually. Let us think of it. As you know that vector is represented by, suppose vector has got, in 3D space or in 2D space, two-dimensional if you are considering. What you are doing, this one vector is sum of multiple vectors, right? One component is along x-axis, y-axis. So we call these, coordinate axes. Along the coordinate axes, you have got different components. Example, think of it for a moment. Think of it for a moment. If you have this block, and this is a big block, right? Big block. With mass m, whatever it is, this is heavy one. Now, a person who is willing to move it, from this point to this point, let's say this point A to point B. There are multiple ways. If one person is strong enough, he can push this, push this like this, and then it will be, coming here. But there is another way also. If a person is, thinking in a different way, what he would do, he has this rope. Say, he has this rope. He has this rope. And he is doing this, basically. Over this, he has taken, he has taken himself in this manner. He is moving and he is pulling it. He is sort of pulling it. He is sort of pulling it. And then moving in this direction, right? Moving here, moving in this direction. So, do you think that he would be able to apply enough force? Because if force he is applying in this direction, if he is applying force in this direction, this block is more likely to get pulled up rather than being moved here. But in actual practice, what happens? This block may moved, this block may be moved in this particular direction horizontally and little bit of vertical also. So if we have the component of this along this direction and along this direction, so what actually we are doing? We are splitting this vector force in two directions, right? So do you think that this component will have same effect as this one? No, this won't be there. So in this manner, if you consider that force, this F can be considered as, this is one vector along x-axis, this is another vector, this is another vector along j cap, along y-axis. This is another vector, right? So this process of splitting a vector into components, we call this components. We call this components. Force has two components. So now this force this force vector is expressed as the sum of the two vectors. If you simply add these two with proper vector addition, you will get the same value as that of this vector, right? So this is basically very important. Why? Because we need to see that the direction of force, okay, fine, you are applying force in this man is applying force in this direction, this man is applying force in this direction, but its effect is also along this axis, along horizontal. So what is that effective force exerted along this x-axis? We need that sort of calculations. We need that sort of calculations, and that is why we have to split the vectors into several components. We call this to be components, right? Component along x-axis, along y-axis, or if it is in 3D, three-dimensional space, this vector can be splitted or broken into three components. So now that vector would be the sum of the three components. The entire effect will be same as that of this same vector, right? If you if you take the individual component, obviously that vector, add them all, you will get the same effect as this. Understood? So this is what resolution of vector is. So let us quickly have the basic definition of resolution of vectors. This is this process of splitting a vector into two or more components in such a way that the combined effect, mind it, combined effect is same as that of a given vector. So here if you see this vector A is written as AX plus AY. This is along x-axis, this is along y-axis, where this is the component. If you simply talk about the magnitude of this, it is AX. Now, how to find out this AX? Magnitude of the component, magnitude of x component of vector A, magnitude of y component of vector A, magnitude of z component of vector A. How do we find it out? Because in that situation, when you are resolving, we need to calculate, as I told you, we need to calculate what is the value of this. If this is theta, think of it, if this is theta, then what is the effect of this? What is the calculation? What is the x component of force? What is the y component of force? That would depend upon what is the angle made with this, made by the vector with this x-axis, or it may be with y-axis as well, like this. If a vector, this is along, this is x-axis, this is y-axis, and if this is given, in this manner also we can find it out. What? The components will be like this. Components will be like this. One component along this, one component along this. So this is obviously fx and this is fy. How to get this? How to get this? We will understand. Just have a look. So if you see here OCB, see what we need to do. Just draw this. You have got this vector. You have got this vector. This is vector A. From the tip of this vector, you draw a perpendicular. You draw a perpendicular on x axis. Starting from here, if you measure this length, you will get the x component of this vector. Right? Similarly, if you draw a perpendicular from the tip of this vector on y-axis, if you measure it from this O, this length would be the y component of vector A. Okay? So now simple trigonometry will be used, and I'm just writing it here. Ax equals A cos theta. You tell me whether it is correct or not. Ay equals A sin theta. You tell me whether it is correct or not. Okay, so why this is so? Let us do it. Let us do it. The magnitude of vector A, OC equals A. A is the magnitude of, what is this? Magnitude of vector A. Okay, magnitude of vector A. Now, if you look at here, OCB, triangle OCB, in triangle OCB, cos theta equals base, which is AX, by hypotenuse, which is OC. That means magnitude of A, the length of this vector would be simply A. So A, and that is why this AX equals A cos theta. Right? In a very similar fashion, if you look into this in triangle again, if you know, no problem, you may take this also, OCB again. This and this are same, no? If you measure this one, you have this AY. That means this BC is also equal to AY. Okay. So if you have in this sin theta equals what? Sin theta will be equal to BC by OC. BC is what? AY. And OC is what? A. So hence you have this result. This result, AY equals this, AX equals this. So this is how we split a vector, right? So basic idea, you got it. Resolution of vectors means splitting a vector into components, right? And how to get that component, that would be based upon what angle it is making with, you know, x-axis, y-axis, whatever your axis you are taking, along which you are actually required to find out the component, right? This has very very large significance. We need to be, master in it, because in NLM, whenever you require, even in kinematics also, you are saying, okay, velocity in this direction is this. Some part of the velocity, some portion, like start with the position vector also. You are saying x component, y component, z component, multiple things. So velocity also have got several components. You may not say that, okay, only along x-axis. If you are describing the motion of let's say aeroplane, so it is going linearly also, it is moving in the it is going up also, so its movement is in the 3D space. This plane, right? This plane and height also. So what you will get? 3D space. Inside the 3D space, motion of a fly, if you will say, right? Housefly or any such insects or something, it would be what? 3-dimensional. So what you need to do, you would not say that, okay, it started from here and only moved in this direction along x-axis or y-axis, or no, not only that, it is a combined effect of this. So net velocity, if you have to get, it has got several components, and several components, what is that several component? You will find out, right, using this process called resolution of vectors. So this was the basic stuff behind it, and let us do few questions like this. Suppose you have F equals 100 Newton, and this theta equals 60 degree. Theta is angle with y-axis. Here in this particular situation, we have taken angle made by this force F with y-axis to be equal to 60 degree. Now, as we have understood, from the tip of this vector, what you will do, you will draw a perpendicular. So this way you will have Fx, you have Fx, and you have Fy. So here Fx would be, if this is theta, this is perpendicular here. Okay, so if you want to draw a triangle, it is already a triangle. You see, name the triangle if you wish to. Name the triangle O, let's say A, and this is B, OAB. So in triangle OAB, okay, if this is 60 degree, so this must be 30 degree, right? This must be 30 degree. Are you getting it? So you have two ways to do this. If you consider this to be the component, this triangle OB, and let's call this C. So if you say this as C in triangle OAC, what will happen? In triangle OAC, what will happen? Just have a look. Cos theta equals, mind it, cos theta equals Fy by F. Why so? Cos theta equals OC by OA. OC is Fy, you can see this, and OA is F, this one. So this we are going to get. So Fy is going to be F cos theta. Right? You may ask this, that there is a confusion. No, there is no confusion. Here theta was made with x-axis. That's why Fx came out to be A cos theta. Here what is happening? Here theta is made with y-axis. You can see this. Let's not talk about this as of now. Okay. You were given this angle. Theta is made with y-axis. Theta is made with y-axis by this force. Okay. So here we have this. So this we need to understand, and it is very simple. Breaking this would be very simple. Okay, similarly, we have Fx. Fx would be what? Fx would be F sine theta. Fy would be F cos theta. Okay, Fy would be F cos theta. Okay, this is very simple. Now, let us take another example. You have this inclined plane. You have learned this, you know what is the direction of weight. Weight is a force? Yes, weight is a force. Weight of a body, not the mass, mind it. Weight of the body. Weight of the body is always directed downward. You are aware of that, because weight is due to the gravitational attraction of Earth. Weight of a body, right? weight of a body. So this body is pulled towards the center of Earth, right? And weight of this body is always directed towards the, if this is the Earth and this is the center, we consider the body is kept here, so weight will be always directed downward towards the center. So obviously we are not like in a city, we are not saying that in that city there are different values of G. All this thing we will talk in in chapter gravitation, where we have a different value of G, in under what condition value of G will change, these things. Otherwise, what we need to do is we simply have to take the value of G to be equal, on the in this area of Earth, within this region, right? So it is simple. So what we are actually doing, we are actually considering that on this inclined plane, if a block is placed, let's call this block is placed like this. This is the block. So weight will be what? Weight will be always directed. Weight will be always directed downward. This is the weight. Okay. This is the weight. And this is the angle theta. This is the angle theta. This is the angle theta. Here we need little bit of basic understanding of trigonometry and geometry, little bit of geometry. So what actually we are interested in finding out? We are interested in finding out the component of this weight along two axes, two directions. Just have a look. One direction we are interested in finding out is this, perpendicular to this inclined plane. Another along this, okay, along this. And another we are interested in finding out is along this axis. So we may consider this to be x-axis and this to be y-axis. Yes, there is a confusion. In such scenarios, in most of the cases, you need to take into account the axis in this manner. This is x-axis, this is y-axis. Okay? So this is arbitrary. We are free to find out the component of a given vector along any given direction. If you know the formula, if you know the concept, then it is quite easy for you to get the components along given axes or given directions. This is very easy. Just have a look. What would happen? A little bit of geometry would say that, understanding of geometry would say that this angle is theta. This angle is theta. How? That also I will talk if you are not able to relate to this. This angle is theta. Okay, fine. Now what we will do? We will simply do one thing. What is that? From the tip of this vector, whose component we are interested in finding out, from the tip of that, you draw a perpendicular on what? On the axis. The axis on which you are finding out the component. So this is the axis, x-axis. We have found this. So make this a parallelogram sort of stuff. Okay, this thing. Now from this, if you draw a perpendicular here, so what will happen? We have this. We have this as one component. We have this as another component of weight. What is weight here? Weight is W, right? So here you will say W equals what? M into G. Okay, so one component. So if this is theta, so this triangle, mind it, this triangle will give us this triangle will give us this thing, you know. This will be FW cos theta, and this would be W sin theta. That means along x-axis you have mg sin theta, and along y-axis, and one more thing that we need to understand, here it is along the, if this is positive y-axis, this is negative y-axis. Okay, so we have this thing. Like this. We need to draw like this. This is the weight, and these are the two components. How to get these two components? We have drawn a perpendicular on x-axis and is y-axis. So this will be mg sin theta, and this will be mg cos theta. Mg cos theta. Mg sin theta, mg cos theta. So is this clear? So how this vector can be represented? So let us talk about this. Let us talk about this. This vector W mg, right? This is expressed in this manner. mg sin theta along x-axis, mg sin theta, this is I cap minus mg cos theta along y-axis. So this is the representation. Understood? So we have this sort of calculations to do while solving problems. There are so many problems, you know, n number of problems we have to do when where we need to actually resolve a given force or given vector along different directions. So this was the basic idea behind how to resolve and how to get the vector, you know, component of vectors along different directions. Understood? So in the next session we will talk about, first of all we will do few questions based on this resolution of vectors and all, and then we will do dot products, the multiplication of vectors. Okay, so till then whatever we have understood, practice properly.